So, last class we were mainly discussing about the measurement of surface roughness, everything, and I hope so. You have got an idea of what you mean by surface roughness, everything. Okay, and what are the techniques all we have discussed with respect to that. So, now we are discussing about the gauges, everything. So, with respect to surface roughness, do you remember the type of irregularities what we have mentioned yesterday? Type of irregularities in the case of surface roughness. There were two irregularities. Can anyone of you say what are the two irregularities with respect to surface roughness? Am I audible?
Yes, sir.
Please tell everyone to join, okay, as soon as possible. So, Mohammed Fateh, can you tell me the types of irregularities in the case of surface roughness? Could
Yes,
you
sir.
tell me the types? Which
Roughness
all?
height, width,
Roughness and
roughness height and width,
roughness height and
width,
weight, oh, not weight,
width,
waveness.
width.
Width of it. Okay, width
Cut
height.
off.
Okay, waveness. Okay. So now already, okay, thank you for that. So already we have discussed about the gauges. So we'll have a small introduction of what you mean by gauging and what it says. Then we will go to the measurements of the screw. Okay. So with respect to the gauging and aspects, everything, what happens is like it is an inspection tool mainly used to check the product dimension with reference to its maximum and minimum acceptable limit. That's what we say with respect to gauging, where gauging is an inspection tool mainly used to check the product dimensions with reference to its maximum and minimum with respect to its maximum and minimum acceptable limit. Then it is generally used to segregate acceptable and non-acceptable products in mass production without knowing the exact value of dimension. This is what happens with respect to the gauging and with respect to gauge, where it is an inspection tool. It is mainly an inspection tool used to check the product dimension. Okay, so it is mainly an inspection tool used to check the product dimension with reference to its maximum and minimum acceptable limit, where it is generally used to segregate acceptable and non-acceptable products in mass production without knowing the exact value of dimensions. So mainly the gauges, what happens, the gauges perform an essential fee services in any scheme of quantity production on interchangeable basis. Then a gauge or limit gauge is a tool or instrument to measure or compare a component. That's what happens then. It is employed in the sense of instrument which is having fixed dimension and is used to determine whether the size of the some component exceeds or is less than the size of the gauge itself. So this is what happens with respect to the gauging, where it performs an essential services in any scheme of quantity production. Okay, so it is an essential services in any scheme of quantity production of an interchangeable basis, and a gauge is a tool or instrument to measure or compare a component. It is mainly a gauge is a tool or an instrument to measure or compare a component. Then it is employed. Okay, it is employed in the sense of an instrument which is having fixed dimensions. It is always employed in the sense of an instrument which is having fixed dimension and is always used to determine whether the size of the dimension or components exceed or is less than the size of the gauge itself. This is what happens when respect to the gauges, where we have the instrument which has a fixed dimension and is always used to determine whether the size of some component exceeds or is less than the size of the gauge itself. That's what happens when respect to gauges, where we have a tool instrument to measure of the component. We always have a tool instrument which is used to measure or compare a component. Okay. So the gauges is mainly perform essential services in any scheme of quantity also. Then the gauges are used for dimension control of the component parts. Okay. Mainly the current gauges. The gauges are all used to for the dimension control of the component parts. Okay. The gauges are used for dimensional control of the component parts and their function being to establish whether or not surface levels lie within the zone specified by the designer. Then gauges must be manufactured and checked with reference to standard of length, which is termed is related to fundamental length standard. The standard of length is then transferred to the gauge to the component. This is what happens with this gauges. So mainly the gauges are used for dimension control of the component parts and the function, which is being established to whether or not surface levels lie within the zone specified by the designer. So it is mainly used to control dimension control and the compound parts, and the main establish the surface level, etc., and the fundamental length, all that factors as such. Then the true value of a gauge is measured by its accuracy and service life, which in turn depends on the workmanship and materials used in its manufacture. Since all gauges are continually subjected to abrasive wear while in the use, the selection of proper material is of a great importance. Okay, the selection of proper material is of a great importance. Then, high carbon steel and alloy steels have been the principal materials for manufacture such gauges. So, in the case of gauges, the true value of a gauge is measured by its accuracy and service life. Okay, that is the true value. Okay, the true value of a gauge is measured by its accuracy and service life, which in turn depends on the workmanship and materials used in manufacture. It mainly depends upon the workmanship and the materials used in the manufacture. Okay, then since all gauges are continually subjected to abrasive wear while in the use, the selection of the proper material is of great importance. Okay, the selection of properties of great importance. Then, high carbon steel and alloy steels have been the principal materials for manufacturing of such gauges. Then the main advantages of gauging are okay, faster checking regarding whether the product is within the specified limit or not can be done. Okay, that's what that's it is mainly related to the faster checking. Okay, it is always related to the faster checking. Okay, it is always related to the faster checking and whether the product is within the specified limit or can be done. Then less dependence, mainly the less dependence on the operator skill, and hence results are not getting affected by the operator judgment. Then more than one dimension of the product can be checked at a time, as well as properties such as roundness, taper, etc., as can be checked at a time. The gauges are economical than measuring instruments. So this is what happens with the case of the gauging. Okay. Then the main limitations of gauging are, but exact value of the product dimensions cannot be known. Okay. Here the exact value of the product dimensions cannot be known, and the accuracy of the gauges is getting affected due to wear and tear with the passage of time. That's what happens. Mainly the the accuracy of the gauging is getting affected to the wear and tear with passage of time. Then it is also useful only for similar product because it's difficult to manufacture and maintain large size cases. It's difficult to maintain and manufacture large size gauges. So these are the basic limitations of limit gauges. Okay, and these are the instruments that we have already discussed. So this is what we happens in the case of gauging, where okay. Then after gauging, we will be having a discussion about the screw thread. Okay, measurement of a screw thread. Okay, measurement of screw threads and gauges. That's what happens. So that that will be like okay, this is what the measurement of screw thread thermology. So these gauges we have done. Okay, gauges we have already discussed. So here now it comes with the screw thread thermology. It's mainly regarding the measurements of screw thread thermology. Okay, so you see this is the threads and this is the basic thread which you have seen with the naked eye. So I hope so you have seen this minor diameter, major diameter, pitch, depth of depth, pitch diameter, etc. So mainly the screw thread. Okay, mainly it's regarding the introduction to the thread measurement. So mainly we discuss the screw thread terminology as it's the main thing. So what happens is it is a helical structure. What happens? You know the screw thread it is mainly a helical structure which convert. Can anyone of you tell me what motion gets converted into to another motion in the case of a screw thread technology by just looking at the figure? By just looking on this figure, can any one of you tell me what type of what type structure, what type of movement is converted to what type of movement? Can any one of you tell me? Should I ask? Amit, can you tell me? Amit,
Yes, sir.
yes, could you tell me what type of movement is converted to what type of movement in this case of the scooter thermology in every aspect?
Sir, zigzag वाले ले.
Yeah, this is the thing. So which type of motion is getting converted to which type of motion? How do you go? As you have done your
Sir,
technical studies, I am just asking. Yes,
rotary.
yes, yes, rotational movement too. Okay,
Uh,
Two, rotary motion. Okay, no problem. Two. Okay, fine. So a screw thread, but I think so you don't know the answer, not an issue. So mainly the screw thread is a helical structure. It is mainly used to convert one simple rotational motion to linear motion, and also to convert rotational torque to linear force. That's what happens. So rotational torque with the help of a hand we'll be doing, and some cases we'll use some instruments to the linear force. That's what happens. So a screw thread is a ridge wrapped around a cylinder or a cone in the form of a helix. So see, this is a ridge wrapped around the cylinder in the form of a common or a helix. So what happens in the case of a screw thread? It is a helical structure which is used to convert what the rotational movement to a linear movement, and also used to convert the rotational torque to linear force. That's what happens. So it is also helical, it's produced by forming of continuous helical groove, uniform section of external or internal surface of a cylinder or a core. So it is used to transmit the power and motion. The screw thread also acts as a temporary fastener. This is what happens with respect to the screw thread terminology. Okay, this is what happens mainly to the screw thread terminology. So by looking at the figure, okay, by looking at the figure, so actually this is the main figure to draw, but this gives a very wide explanation and shows you how we can consider all this. So these all are important terms like pitch line, major diameter, minor diameter, okay, depth, pitch, crust, crust, crest, root, okay, crest, root, flank, then thread angle, addendum, depth of thread. All this plays a very crucial role in determining the nomenclature of his screw thread. Okay, nomenclature of his screw thread. So this is actually it also used as a fastener in some cases also. So now we will start with okay. First we will see this is the major. So this is the major diameter, and this is the major diameter, and this is the minor diameter. So this major diameter, in some cases, we can say it as also nominal diameter, while the minor diameter or core diameter can be also be called as a root diameter. Okay, so this is what happens. So major diameter can be also called as nominal diameter, and the the minor diameter or core diameter or root diameter can be also named. Okay, that's what happens with the help of a screw thread terminology. Okay. So with respect to screw thread terminology, what happens is like first one is a major diameter or nominal diameter where it is defined. Okay, it is always defined as the diameter of an imaginary cylinder. Okay, it is always defined as the major diameter. It is always defined as the diameter of an imaginary cylinder that bounds the crest of an external thread or root of an internal thread. It is the largest diameter of a screw thread. That's what happens. So in one word, what you can say, it is the larger diameter of a screw thread. Okay, then what happens? It is always defined as the diameter of an imaginary cylinder. It is always defined as the diameter of an imaginary cylinder that bounds the crest of an external thread. It always bounds the crest of an external thread, okay, or root of an internal thread. So it is always the largest diameter of the screw thread. That's what happens with respect to the major diameter. It is also named as nominal diameter. Then the second one is regarding the minor diameter. The second one, okay, the second one is mainly regarding the minor diameter or core diameter or root diameter. Okay, so this is what happens. Now the minor diameter is over here. This is the minor diameter where it is defined as the diameter of an diameter of an imaginary cylinder. Okay, that bounds the root of an external thread or crest of an internal thread. It is the smallest diameter of the screw thread. In the previous case, it was the largest diameter of the screw thread, while in the case of minor diameter, it is the smallest diameter of the screw thread. Okay, it is the smallest diameter of the screw thread. So that's what happens with respect to the screw thread. Then what happens is like the major diameter always it is defined as the diameter of an imaginary cylinder, okay, that bounds the crest of an external thread. Okay, bounds the external thread, it is a larger diameter of screw thread, while minor diameter, core diameter, root diameter is defined as the diameter of an imaginary cylinder that bounds the root of an external thread or crest of an internal thread. Then it is the smallest diameter of the screw thread. Here it is the smallest diameter of the screw thread. Then the third one is pitch diameter or effective diameter. Okay. Then the third one is pitch diameter or effective diameter. So in the case of pitch diameter or effective diameter, what happens is like effective is like this is the pitch diameter, and this is also named as the pitch line. Okay, so In the case of pitch diameter or effective diameter, we can say it is also defined as the imaginary cylinder diameter, where the surface of which would pass through the thread at such points to make equal width of the thread and width of spaces between the threads. That's what the main requirement of the pitch. Okay, see, this is a pitch. This is the pitch. Okay, pitch. So what happens is this is the we can name it as pitch diameter. What's mean by that? Means it is always what happens. It is defined as the imaginary cylinder diameter. Okay, it is defined as the imaginary cylinder diameter where the surface of which would pass through the thread, the surface of which would pass through the thread at such points as to make equal width of the thread, at such points as to make equal width of the thread. Okay, at such points as to make equal width of the thread, equal width of the thread. Okay, such points to make the equal width of the thread and width of the spaces between the thread, and always width of the spaces between the thread. You should not have a confusion regarding the pitch diameter and the pitch. So pitch diameter, I'm telling it again, it is defined as the imaginary cylinder diameter where the surface which the surface of which would pass through the thread at such points to make equal width of the thread and width of the spaces between the threads. Then, with respect to the pitch, it is always the axial distance. It is always the axial distance between two similar points on adjacent threads. This is the axial. See, where is it? It's the axial distance between the two similar threads. It's actually two similar threads. Okay, two similar threads of adjacent threads. It is measured in millimeters. Okay, it is always measured in millimeters. Then we comes with the lead. It is defined as the axial distance. It is always defined as the axial distance. It is always defined as the axial distance which a screw thread advances in one rotation of the nut. That's what we mean by lead. Okay, lead in one word we can say is it is defined as the axial distance which a screw thread advances in one rotation of the speed. That is named as lead. Okay, then comes crust. See the figure, then you can see the crust. Okay, this is the crust. Okay, crust means what? It is the top surface. It is the top surface generated by the two adjacent flanks of the thread. So in the case of crust, it is the top surface generated by the two adjacent flanks of the thread. Okay. In this case, crust means it is the top surface. It's merely a top surface generated by the two adjacent flanks of the thread. Generated by the two adjacent flanks of the thread. Okay. Then, in the case of root, okay, in the case of root, it is the bottom surface. Okay, it is the bottom surface. Okay, it's the bottom surface generated by the two adjacent flanks of the thread. So in that case, what happens? It is the top surface. Crust was the top surface generated by the two adjacent flanks of the thread. And in this case, it is a root. Root means what? You can see in the figure. Okay, where's the root? The root is over here. Root. So root is what? It is the bottom surface generated by the two adjacent flanks of the thread. It's the bottom surface. Okay, generated by the two adjacent flanks of the thread, mainly generated by the two adjacent flanks of the thread. That's what happens. Then comes the depth of thread. Okay, then comes the depth of thread. See, you can see the cursor. Then comes the depth of thread. So what happens to the depth of thread? Depth of thread is it is defined as the perpendicular. It is defined as the perpendicular distance between the crust and the root. So depth of thread, it is mainly defined as the perpendicular. Okay, it is mainly defined as the perpendicular distance. Okay, it's mainly defined as the perpendicular distance between the crust and the root. Okay, so in the case of the root, what happens is in the case of depth of thread, what happens is it is defined as the perpendicular distance between the crust and the root. What you mean by crust and what you mean by root, we have just explained now, just explained before. Then what happens? Flank. Flank means what? The inclined surface which joins the crust and the root. Flank means it is mainly the inclined surface. Okay, flank is mainly the inclined surface which joins the crust and the root. Then that next one is the angle. Okay, an angular depth or angle of cut. This include the angle between the two flank surfaces. Okay, it mainly include the angle between the two flank surfaces. Then okay, then we can say in one word what I can say, we can say screw thread. What do you mean screw thread? A screw thread comprises of a helical groove of specified cross-sectional shape where the helix angle can be determined. What happens? A screw thread comprises a helical groove. It's always a helical groove of specified cross-sectional shape. It's always of a very specified cross-sectional shape where the helix angle of the thread can be determined by tan alpha is equal to P by pi d, where alpha is the helix angle, P is the pitch, and small d is the diameter. That's what happens. So, in the case of screw thread, this is what happens. Then, okay, see, so we have explained it in a systematic way. Then we have the slope of thread. What is slope of the? It is defined as a half the pitch of the thread. Slope of the thread is always defined as the half of the pitch of the thread, and the flank angle. It is the angle between the individual flank. Okay, it's always the angle between the individual flank, which is perpendicular to the axis of the thread, which passes through the vertex, which is always perpendicular to the axis of the thread, which passes through the vertex. The next one is helix angle. Just the helix angle is what? It is the angle made by the helix. Helix angle is always the angle made by the helix of the thread at pitch line with plane perpendicular to the axis. Then comes the addendum and dedendum. We can see in the figure addendum and dedendum. Addendum, it is the it is always the radial distance between the major dia and the pitch dia. Okay, so it is always the radial distance between the major dia and the pitch dia. Dedendum is it's always the radial distance between the minor dia and pitch dia. Dedendum is always the radial distance between the minor dia and the pitch dia. This is what happens. So addendum means it is a radial distance between the major dia and pitch dia. Then addendum means it is a radial distance between the minor dia and the pitch dia. Then thread angle. Thread angle, it is the angle of cross section, which is standardized. Okay, the angle of cross section, which is standardized as to 60° in V, and threads, but any angle can be used in threads, but any angle can be used. Then comes the tolerance, where the following are the requirements for the proper external and internal thread engagement, where the external thread and internal thread must have sufficient contact at the flank. The external thread, internal thread must have enough engagement. So these are the various types of the major parts of it in the case of a nomenclature of thread. So this is what happens with respect to the screw thread terminology. Okay, then what happens is like the screw is mainly the crust. I have told the peak edge of the screw and the root, which is the bottom of the screw. Then the thread angle between thread face. Then the flank angle, surface between the crust and the root. So this is what you can say it as the internal thread. You see, this is what you can say the internal thread, and this is what you can say the external thread. And what is the purpose of root and cross, which we have already told. Okay, which we have already told. Then we have the major dia and minor dia. So major dia we have explained, largest dia and the screw thread. So this is the major dia, which is the largest from the first top to the next top. So that's what happens. Okay. Then minor is always from the bottom. Okay, the bottom of the to bottom. That's what happens. So that's between the largest dia and screw thread and minor, the smallest dia and screw thread, which is more the major dia and minor dia. Then what happens is pitch and pitch. Pitch is what? Which is distance between the two consecutive crusts or root. Which is mainly between the distance. So it is always the distance between the two consecutive crusts or root. Okay, which is mainly the distance between the two consecutive crusts or root. Then lead is the distance a screw will advance when turned 360°. Okay, the lead is always the distance a screw will advance when turned 360°, and lead is equal to the number of starts into pitch. Okay, mainly the number of starts into the pitch. That's what happens in each screw. Then see, this is the effective dia or pitch dia. This is mainly different than the effective dia or pitch dia, where we have major dia, pitch diameter, and minor diameter, and where it is representing the pitch, crust, angle, flag. All this are to be taken into elements when considering the effective dia or the pitch dia. Okay, these are the factors. Then the mainly the measurements of diameter of external thread. It is always done with the help of an ordinary micrometer or bench micrometer. Okay. So the major dia measurements, the measurements of major dia of external threads can be only done by ordinary meter or bench micrometer. Okay. Then we have calibration that we have already discussed. That's why in the case of ordinary micrometer, what happens in the case of ordinary micrometer? It is mainly used to find the dia of the thread. It is mainly used to find the dia. It is mainly used to find the dia of the thread that we should calibrate the micrometer using gauge cylinder. That's what happens with gauge cylinder. So in the case of ordinary micrometer, to find the dia of the thread that we have to calibrate or we should calibrate the micrometer using the cylinder. Mainly by using the cylinder, we have to calibrate the micrometer. That's what happens to find the dia of the thread where we should calibrate the micrometer using the gauge cylinder. Okay, that's what happens gauge cylinder. Then we have the cylinder gauges. Cylinders are according to the standard size, similar to slip gauges. Did you see this anywhere before? Anil Suresh, did you see this box anywhere before?
Sir, lab.
Ah. So, what was the requirement of slip gauges while doing the laboratories? Yeah,
Measurement and accuracy.
To measure and to calibrate the instruments, everything we were using the various types of slip gauges. Okay. So, regarding the slip gauges, where do we find the dimensions? How do you understand this slip gauge is this much amount in size? Andrew,
I, ah,
how do you
I,
understand?
അതിൻ്റെ അകത്ത് കാണിക്കൂലേ?
How so?
ഈ
The measurements will be written on top of it. That's what the measurements will be always on top of it. That's what I'm thinking. Okay, okay. Then cylinder gauges means which is mainly cylinders of standard size, then similar to slip gauges. That's what happens. Now we see we have an ordinary micrometer for measuring the instrument. So what happens is you see the measurement is taken on the gauge cylinder size as S approx equal to the size of the thread. Let the reading be R1. Then measurement is taken to the thread. Let the reading be R2. So this is what happens in the case of an ordinary micrometer, where the measurement is taken on a gauge cylinder of size S. Okay, where always a measurement is taken on the gauge cylinder of size S, approximately equal to the size of the thread. Let the reading is R1. Then measurement is taken of the thread. Let the reading be R2. So then major diameter D is equal to S plus or minus R1 minus R2. If S is lesser than the size of the thread and if S is greater than the size of the thread, this is what happens. So this is what happens in the case of an ordinary micrometer, where in the case of an ordinary micrometer, what happens? The measurement is taken on a gauge cylinder of size. Okay, in the case of an ordinary micrometer, the measurement is taken on a gauge cylinder of size, approx equal to the size of the thread. It's always approximately equal to the size of the thread. Let the reading is R1 and the measurement is taken of the thread. Let the reading be R2. Then the major diameter D is equal to S plus or minus R1 minus R2. So if S is always smaller than size of the thread and if S is greater than it is plus or minus will be mentioned. Okay. Then this is a bench micrometer. Okay. This is a bench micrometer. This is the okay. So here we have a micrometer head and this is here we have a field indicator. So here we have two scales. Okay, so when it coincides only we measure. So what is the mainly purpose of a bench micrometer? Can anyone of you say? What is the main purpose of a bench micrometer? Can anyone of you say? Agash came. Could you tell me what is the purpose of a bench micrometer? What's the requirement? You have already used this micrometer for doing experiments in our lab, right? Not the bench one. You have used micrometer. So You can tell me.
ആക്യുറേറ്റ് ആയിട്ട് മെഷർ ചെയ്തിട്ടാണ്.
That's for every micrometer, right? What's the what's the difference? Tell me. You can say it's a type of gauge or a tool
സാർ
used for what? Used for what?
മെഷറിങ്
Used for measuring
ഇൻസ്പെക്ഷൻ
what?
സ്ലിപ്പ് തന്നെ സാർ.
Hmm? Mainly used for measuring.
ലെങ്ത്തും കാര്യങ്ങളും മെഷർ
Mainly
ലെങ്ത്തിനെ
used for
മെഷർ.
measuring the length. Length. Then what happens? Yes, that's what which typically resides on a workbench that measures length, whose accuracy and precision is approximately 20 microns. Okay, that's whose accuracy and the precision is almost equal to 20 microns. That's what I want to accept from you. Okay, so this is what happens. So now, can you tell me what is the working principle of a micrometer? So we are taking a bench micrometer. So by seeing this, can you tell me the working principle of a micrometer?
സർ വർക്കിംഗ് പ്രിൻസിപ്പിൾസ്.
Or just tell me the working principle. Okay.
സർ ആദ്യം അതായത് സീറോയിൽ സെറ്റ് ചെയ്ത്
Why can't you speak in English?
സർ ഫസ്റ്റ് വി ഹാവ് ടു മേക്ക് ദി മെഷർ സീറോ അങ്ങനെ.
How do we measure zero?
We have to adjust that
Yeah, what? Scale. What scale?
length measure in a scale.
Okay, measuring scale. Okay. Then
And we have to place the
place the.
sir ഇത് measuring ചെയ്യേണ്ട സാധനം.
That's what.
Measuring.
You have to table the measure. You have to keep the middle of it, and you have to use the measure. Right? So what happens? The working principle of a micrometer is based on a screw and nut. Okay, we can say screw and nut arrangement. Do you remember that? While we are doing in the lab, they had a screw and nut, right?
Yes.
What happens if you tight more? It will just what happens? It will just move on. That's what. So the working principle of the micrometer is based on a screw and nut, where the rotational movement is a linear movement. Okay. So what happens? The screw moves linearly up one pitch. This is what happens in the case of a bench micrometer. Okay. So mainly in the case of bench micrometer, this is mainly used for ferrous and non-ferrous, electric cable, enameled wire, all that purpose only we are using bench micrometer. So we have holding centers to hold the part, the measuring anvils to measure, the micrometer head to check, and the fluidic indicator to measure the pressure applied on the thread. So all these factors are considered. Okay, in the case of a bench micrometer. Okay, in the case of a bench micrometer, or just you can say micrometer. So this is what happens. Then the measure. How do we take the measurements of a bench micrometer? Okay, what happens? Measurement is taken on a gauge cylinder. Size S is approximate. Equal. It's always equal to the size of the cell, and measurement is taken the thread. Let the readings be R2, where the major diameter D is equal to S is equal to plus or minus R1 minus R2. That's what happens if the measuring when is taken in the bench micrometer. What happens? Measurement is taken on a gauge cylinder of size S, mainly of size S, then approximate equal to the size of the thread, approximately equal to the size of the thread. Then let the reading R1 and measures taken thread at R2, and then the diameter D is equal to S is equal to plus or minus R1 minus R2. So this is what happens in the case of a floating carriage micrometer. You can see the major dia and minimum dia. What we have already explained. Can anyone of you tell me what is the difference between major dia and minimum dia? Major diameter, minimum diameter. Karthik, can you tell me? Karthik,
Yeah.
will tell me
Santa question.
what is the difference between major dia and minor dia? I have already told the starting of this class while telling the view of screw terminology.
മേജർ എന്ന് പറഞ്ഞത് ലാർജസ്റ്റ് ഡയമീറ്റർ,
Okay.
മൈനർ സ്മോളർ,
From where to where? From where to where?
അത് അറിയില്ല.
Smaller and larger. Okay. You can say it as what? Outer and inner. Okay. That's the most appropriate term. Okay. Outer and inner. Karthik, are you hearing?
Yes, sir.
Okay. It's mainly the outer and the internal thread. So when what happens to the major diameter, it is always the largest diameter of screw thread, the outer one. And then minor is it is the smallest diameter of screw thread, that is the minimum one. That's what happens. So okay now. So the floating carriage micrometer is similar to the bench micrometer. Here the carriages can float on the perpendicular directions. It can be used to measure the major and minor diameters of the thread. So this is what happens with the help of floating. Then we have a floating upper carriage and lower carriage. Then two-piece, three-piece method is available, where okay, where what happens is like okay, this floating gauge measurement, we have two carriages. That's upper carriage, which contains the anvils, fluidical indicator, micrometer. The lower carriage immediately comes to the base, contains the center support to the base. The thread what happens, all that happens. So this I also you have already knowing. Base means what contains the centers which give a support for the whole system to accommodate the workpiece in order to do the functions, in order to transfer the power from the external source to the medium, everything base will help in order to stand with the high withstandability. Okay. Then we have two carriages where one is the upper carriage and lower carriage. Upper carriage mainly contains anvils, fluidical indicator, micro level, etc. Okay. Then in the case of 2V piece method, okay, to find the minor dia, measurement using floating micrometers used, always measurement using floating micrometers used. It is always used to find the dia of the thread. It is always used to find the dia of the thread. Then we should calibrate the micrometer using the gauge cylinder. We should always calibrate the micrometer using the gauge cylinder. That's what happens in the case of a 2V piece method. Okay, that's what we happens in the case of a 2V piece method. So here we have a to find the minor diameter measuring using 14 meter. To find the dia, we should calibrate the micrometer using the cylinder. So this is what happens here. Now we have a pitch. What you pitch measurement? That is the screw pitch measurement. Toolmaker's microscope will help you. Then pitch measuring machine. So this is the pitch. Then screw pitch gauge and pitch screw gauge. So I have hope so you have seen this. Okay, it is mainly used for measuring the internal threads, everything. So first we'll start just to have an overview. Okay, what do you mean by pitch? Distance between the two constitutive crusts out of crust or root. So can anyone of you tell me what do you mean by crust and what do you mean by root? I shall ask Agash KM. Could you just tell me what you mean by crust?
Crust.
Then the root are almost similar. I have told all this today when just in this class before starting when we are discussing about the truth and methodology. I showed the figure also. So could you just tell me?
And
Crust.
രണ്ടും അതിന്റെ ബോട്ടമും അല്ല ടോപ്പ് അല്ല സർഫേസ്.
Two adjacent flanks of the thread. So what it is generated? In the case of crust, what is generated? Is it the top surface or the bottom surface? In the case of crust, which part gets generated by the use of two adjacent flanks of the thread? Agash, are you there, right?
ഓഹോ
Akash.
സർ
Uh,
സർ ഞാൻ
can any one of you tell me what's the difference between crust and root?
ടോപ്പ് ടോപ്പ് സർഫേസ് അല്ല
Hmm.
ടോപ്പ്
You can
സർഫേസ്
what?
അല്ലേ
Top
സർ?
surface generated by the two adjacent flanks whole thread. That's what crust. Okay, root is the bottom surface generated by the two adjacent flanks. That's what. Okay, so it's always the distance between the two consecutive crusts and or root. Okay, that's what happens. Now, in the case of screw pitch gauge, what happens is simple device to measure the pitch of the thread, typically external. So they have various teeth profile and not a precise instrument. That's what happens to the screw pitch gauge. So simple device, you can see the figure. The figure still represents. Okay, see this thing. Simple device to measure the pitch of the thread, typically external. They have various teeth profile, not a precise instrument. So now this is the plug screw gauges where it is mainly used for internal threads. Then it can be used to measure the pitch, major dia and minor dia. It is also a go or no go gauge. Okay, that's what happens with the help of plug screw gauges. Okay, then similar to ring screw gauge, what happens is it is a gomino type, can measure the pitch of the external head. And this is what caliper gauge. Okay, what is caliper gauge? It has two end wheels and measuring scale. So I am just noting down that these are extra contents with respect to that of our measurement of threads. Okay, so then here what we have is a pitch measuring machine. Okay, so you can see this is the pitch, this is the stylus, everything. So position of the stylus at the root of the thread. You can see the position of always the stylus at the root of the head, which coincides with the pointer position with the reference line. So you will have a basic idea while learning the what while learning the various or advanced. Okay, while learning the various advanced measuring device, which will be taken to the next topic, where we will have the Taylor's and surface spot or so many various types of measuring devices. Not only on the surface, but also the threads everywhere. It will be employed for account requirements. So in that only we will be discussing regarding the stylus. Okay, the stylus, what you mean by the stylus, everything. So here what you just remember that position the stylus at the root of the thread, where which coincides the pointer position with the reference line. Then note the initial micrometer reading. For this only we are using. Okay, so this is what happens. So this is what happens with respect to the micrometer to move stylus. So this is it. So these are the various factors. So all this, okay, all this measurements of screw gauge, everything, okay, mainly is related to which type. The basis what regarding what? Rahul Rajiv, can you tell me what is the base regarding this? Rahul,
Sir,
what is the base regarding this? Can you tell me what is the base regarding this? It is always regarding the threads. Okay, it is always regarding the threads. Okay,
yes.
okay, it's always regarding the threads. That's what happened. It's always regarding the threads of the purpose. So we are measuring all the threads. Like, can you tell me the different types of threads employed then? Any one of you? It is the triangle shaped threads, square shaped threads, and trapezoidal shaped threads. So these are the various types of threads which are mainly employed. Okay, that's what happens. So this will be learning more in our next class, where we will be studying about the advanced measuring devices. Okay, where we will be studying about the advanced measuring devices. Okay, okay. I'll stop the class.